Good morning. I am doing a quick video today to talk about ring end gaps. I had a few questions on an Instagram post of some ring end gaps, so I'm going to do a quick video and explain a little bit more about ring end gaps and what they mean, how we measure it, and a little bit of maths that goes into the engine building side. Okay guys, so here we've got our LSV8. This happens to be an LS1. It's an 8-cylinder, so because we've got 8 cylinders, 4 cylinders on this side, 4 cylinders down that side, and into those corresponding cylinders go 8 pistons. So what exactly is a piston ring? Well, a piston ring, and that's one there, is a mechanical seal. It's a steel ring that seals gas pressure. It's fitted to the piston and seals the high pressure, high temperature gas from escaping down past the piston so that the pressure can force the piston down the bore. As you can see, the ring has a lot of end gap, and this is it's like spring steel. Okay, so it's what we call tension. The ring's got a lot of tension on it, so it has to be compressed down like that to fit into the cylinder bore. So it's always got pressure acting out onto the cylinder walls. If I can get this one in this bore with one hand without dropping the phone, there we go. Okay, so you can see once it's compressed down in the bore, we've got a little bit of a gap there, and here's one next to it. And the gaps on these rings have already been done. We've already done these gaps, and I know they're okay. Yeah, so that's a piston ring, and that ring slides up and down the bore with the piston to seal gas pressure. Okay, so why do we have end gap? Well, first of all, we wouldn't be able to fit the ring onto the piston if it was a complete circle. We have to have a gap to fit it to the piston itself. Here's a ring on a piston. Okay, so it goes in the piston, has a series of grooves. Okay, and we have a top piston ring which seals compression going down the bore. We have a second compression ring which helps anything that gets past the first ring and also helps to scrape oil down the bore. And in the third groove is what we call our oil rings or oil control rings, which scrape oil off the bore as it's going down the bore to keep the oil in the bottom of the engine and the gas pressure on the top of the piston, and the oil down the bottom of the cylinder bore. Okay, so what sort of temperatures are we seeing in combustion? Sort of typically up around 600 degrees C or more, depending on what type of engine it is, whether it's forced induction, naturally aspirated, what sort of RPM, what compression. So, but the other reason we need an end gap, besides needing to obviously fit them to the piston, we want the gap as small as possible when it's installed. The smaller the gap is, the less gas pressure is going to bypass down through that little gap there. Now, once the piston is installed, you've got to imagine that we're not seeing that whole gap exposed. The piston will come right out almost to the cylinder wall, and it will only be the last little fraction of that gap that's really going to be exposed in a engine that's built right. So if we have too much gap, we're going to have gas pressure bypassing through the gap. If we don't have enough gap, as the piston ring gets hot and expands in length, the ends will come together and butt, and then if we get hotter from there, it will try and expand outwards, which it can't because it's contained in a cast iron liner, and we'll then have a situation where that starts to seize in the bore or lock up completely and break the piston. So not enough is no good, too much is no good, and let's have a look at how we measure it. Okay, so this is a set of feeler gauges, okay, and this here is a tooth thou, what we call a tooth thou feeler gauge. Okay, you can see it written on the top there, 0.002 of an inch, which is 0.051 millimeters. Okay, so that's tooth thou. This one here is 19, which happens to be the feeler gauge that I use to measure the end gap on this ring here. So we just insert the feeler gauge down into the gap there to check its depth. So we've got a full set here of feeler gauges, all differing around about 1 thou apart. So what's thou? You hear people talk about thous, 1 thou, 3 thou. What is it? A thou is a fraction of an inch. It's taken from, if we take a 1 inch block, okay, like we've got here, we go to, which is about 25 mil. So there we go. That's around a 1 inch piece of steel. If we were to take that piece of steel like a loaf of bread and slice it into 1,000 pieces, we would end up with 1,000 of these, wafer thin. To give you an idea, this piece of paper here is about 4 thou thick. All right, and this feeler gauge is 2. 1 thou is about the thickness of regular household alfoil. Now, this is where things start to get a little bit interesting. With our rings, and this happens to be a set of JE rings from the US, they give us some guidelines as to how much end gap our rings should have when they're installed in the bore. So let's just look at the high performance street and strip, naturally aspirated. They're suggesting 4.5 thou, 0.0045 of an inch per inch of bore. So for every inch of bore diameter that we have, they're suggesting 4.5 thou in end gap. The logic behind that is that the bigger the bore, the longer the ring is that goes into the bore and the more expansion that you're going to have, so the more end gap you're going to need when it gets hot. So they're suggesting that for a 4-inch bore, we have 18 thou. Okay, that's just 4 multiplied by 4.5 thou is 0.018 inches. Now let's have that's okay. They don't suggest on here whether that's for a cast iron block, an aluminium block with a cast iron liner, or an all aluminium block where the rings run directly on the aluminium itself. And so we've got to have a look at the thermal expansion of the cylinder block to really work this out. And let's have a look at how that affects the end gap. Okay, so we've looked at the suggested ring end gaps from JE, but they don't go into the material of the block or any specifics like that. It's a rough guide. Now, a little bit of a math lesson, bit of a refresher, if you like. Pi equals 3.142. Okay, so that is very important to keep in mind when doing end gaps. That tells us that for every 1 thou, which is 0.001 of an inch, for every 1 thou of growth in diameter of our cylinder bore, when it gets hot and expands above what it is in the workshop today, our circumference of that bore is going to increase by 0.003142 inches. Let's keep it simple. Let's forget the decimals. Okay. In layman's terms, for every 1 thou of bore growth, we're going to have 3 thou increase in circumference that piston ring has to cover. So let's say that block expands in bore size 2 thou, and we've seen what 2 thou is. I've shown you the feeler gauge. It's a minute amount over 4 inches. It's a drop in the ocean, but it ends up being a big number because our end gap with 2 thou of bore growth in diameter, our end gap is going to increase by 6 thou. So we've got to keep this in mind when we're doing end gaps for a cast iron block, which grow very little, to an LS block which grow a lot crazy sometimes. So when we do end gaps for a race engine, we just got to make sure then that we give the engine time to warm up, get the water temperature up, get the oil temperature up before the driver goes out and gets stuck into it, because otherwise the ring end gap will grow around. The ring is going to get hotter much more quickly than the bore essentially, and your ends can butt together and go out and seize the engine before the block's had time to get warm and relax and grow. So with a set of performance rings, they're often called file back rings, because when we get them directly and we put them in the cylinder bore, they have no end gap And a lot of time you can't even get these into the bore because the ends butt together. So why do we get them with no end gap? We get them with no end gap so that we can file into the ring. With a machine, we can file the ring to the exact gap that we want. If we get a factory supplied low end, regular performance, not high performance, but a regular performance ring, it'll come with rings that are already gapped, but more often than not, we put them into the bore and the gaps are too large. It's all larger than what we would like, which leads to more what we call blow-by. Blow-by being the gas that goes down into the bottom of the cylinder block and bypasses the ring. So generally speaking, the better the piston ring seal, the more air and fuel it will draw into the engine when the piston goes down the bore. And then when the piston comes back up and compresses that air and fuel, less of that pressure is going to escape past the ring, particularly when our spark plug fires that air and fuel mixture and our cylinder pressure goes from, say 180 psi to 14 or 1500 psi. So anyways, yeah, that was more than just a quick chat on piston rings. I was going to try and do it in less than a minute, ended up being five minutes, but yeah, a bit of interesting insight for those that are interested. Cheers for watching.